Alright guys, sorry I can't make it in today. My son's got the flu, so I'm at home with him. We're going to continue on his plan though. Let's start off by doing a quick homework review. 18.1 consolidation activity. We're going to start off with the first one. We're going to simplify by each expression by applying the distributed property. Really all I wanted to see here was that you guys could actually get a little bit more practice with the distributed property. We'd have to do 2 times 3x and get 6x, and 2 times the 4, but the 4 is negative, so that would be negative 8. The next one I have to distribute that negative sign to both pieces, so it's going to give me negative x, and negative times negative will give me positive 3. Got negative 5 times 2, which is negative 10, and negative 5 times negative 7, which is positive 35x. And then I've got 1/4, and that could be a tricky one. But we'll treat it kind of the same way we would multiply fractions. Now, 6x and 10, those aren't really kind of like fractions. They're just hidden fractions like we talked about before. You could write any number as a fraction. So this would be like 6 over 1, and that would be 10 over 1. So when I multiply and I distribute, I'm still going to distribute the 1/4 times the 6x. Now I do top times top, so 1 times 6, which is 6x, and bottom times bottom, which is 4 times 1, which is just 4. I also have to distribute that 1/4 to the 10. 1 times 10, and that's a negative 10, so that's going to be negative 10. And 4 times 1, which is just 4. So again, we do the numerator times the actual number, and then the denominator times the invisible denominator of these numbers. Or you could just put 6 over 4, 10 over 4. All right, we're going to simplify these though now, because 6 over 4, we could reduce that fraction, take divide the top by 2 and the bottom by 2, and we could really turn that into 3/2 x minus, divide the top by 2, divide the bottom by 2, 5/2. So let's go ahead and turn that into 3/2 x minus 5/2. You could have also done a decimal there. I know that some of you guys feel a little bit more comfortable using the decimals. Could have changed that 1/4 into really 0.25 and distributed the 0.25 to both terms. That would have been perfectly fine as well. Alright, example number 2, simplify by combining like terms. Really all I wanted you guys to do is combine your stuff, so 3x can be combined with negative 3x. They cancel out because it's a zero pair. And then 2y can combine with 6y. That's a positive 2y plus 6y, so that should have given me 8y equals 24. In example B, we've got 2xy plus 2xy. They both have the x and the y. That's going to give me a total of 4xy. I'm going to look for my other terms that combine. Positive x combined with a negative x, that's a zero pair, they cancel. And then finally my 3y combined with my plus 3y, that's a zero pair as well, they'll cancel. So 4xy equals 96. Now notice we didn't actually solve anything on these because it just wanted me to simplify by combining like terms. Example C. It's a little tricky because of that equal sign in there. Due to the fact that it has the equal sign, I still want to combine my like terms. I want to get my n's with my n's, but the problem is they're on two different sides of that equal sign. So I have to eliminate them. We're going to go ahead and do that by eliminating the n on the right side. If it's minus 2n, I will plus 2n, and those cancel. And then I'll plus 2n over here. So that gives me 2n plus 2n, which is 4n minus 3m equals 3m. I'm going to go ahead and get rid of that 3m now. So I will add 3m, and they cancel, and I'll add 3m. And that's going to leave me with a total answer of 4n on the left side equals 3 plus 3m is going to give me 6m on the right. 4n equals 6m. And my last one here, 2.5a plus 4.2b plus 16 minus 4.2b plus 2.5a minus 3c. I'm going to look and see if anything cancels right away. And a couple things do cancel. I see that my 4.2b minus 4.2b, I can get rid of them because it's a zero pair and they're on the same side of the equation. So they're gone. Then I'm going to try to get rid of, well, this 2.5a here and this 2.5a. I can combine those, but the problem is that they are on different sides of the equal sign, so I cannot combine them. In fact, what I have to do is eliminate one of them from one side. So I'm going to take and I'm going to eliminate, let's eliminate this one over here, that plus 2.5a. So I'm going to subtract 2.5a and they cancel, but I'll also subtract 2.5a on the other side, and what ends up happening is that these cancel too. So I'm left with 0 equals 16 minus 3c. So you could stop here, but if you wanted to take it kind of that next level, we could also combine 0 and 16 because they are like terms in the sense that they don't have a variable. Problem is they're on opposite sides of the equal sign, so I have to do something about that. I can't just combine them. I have to eliminate one, and I'll eliminate the 16. So I'll minus 16, and I'll also minus 16 from the other side. 0 minus 16 is going to give me negative 16, and I still have the negative 3c, and then I would be done. There's nothing else I can combine because there are no more like terms in that problem. Now let's go on to that last one. I want you guys to solve each equation for the variable indicated. We've got x plus y equals 7, solve for x. So really this one, what you were trying to do is get the x all by itself. So we had x, I'll subtract y, minus y from both sides. X equals 7 minus y. Let's go ahead and look at, let's do C real quick. We'll do C. Solve for x, 4y plus 3 equals 2x. That's pretty easy because I got to get that x all by itself. All I have to do is divide by 2, and those cancel, and divide this whole side by 2. So your answer for that one is x equals 4y over 2 plus 3 over 2. And you guys might not be used to seeing it like that. Maybe you'd be used to seeing x equals 4y plus 3 all divided by 2. But remember what I said, we can actually distribute that 2 to both things. So the 2 gets distributed to the 4y, and the 2 gets distributed to the 3. So I have to divide both terms by 2. So another way to write this would be 4y divided by 2, because we distribute that way, plus 3 divided by 2. We distribute that way. I could simplify that a little bit then. 4 divided by 2 is going to give me 2y, plus 3 divided by 2. That'll give me a fraction, so I'll just leave it as 3 over 2. So your full answer on that could be 2y plus 3 halves. All right, we're going to keep going here just for a moment and check 2 more problems from the homework last night. I want you guys to solve the system of equations. We're on the actual homework page now. Consider the following systems of equations. We've got y minus 2x equals 4, and 2x plus 3y equals 28. Solve the first equation for y. Now solve the systems using the substitution method. I want to make sure that you guys really got this down. So we're going to solve the first equation for y. I've got y minus 2x equals 4. Solve it for y. That means I'm going to add 2x to both sides, so I get that y all by itself. And I really find out that y equals 4 plus 2x. Now solve the system using the substitution method. So really what I'm going to do is I'm going to go ahead and substitute, oops, sorry guys, I'm going to substitute 4 plus 2x anywhere I see a y in the other equation. So right here I see a y, and instead of the y I'm going to substitute 4 plus 2x. So that was 2x plus 3y equals 28. And I got that from this equation right here. Because we solved the first one, so we plugged that into the second one. Now we said instead of y, we're actually going to substitute 4 plus 2x, 4 plus 2x, and we're going to solve this through now. Because we got one equation, one variable. 2x plus distribute the 3, so that's going to give me 12, plus 6x equals 28. Combine your like terms. 2x plus 6x is going to give me 8x plus 12 equals 28. I'll subtract 12 on both sides. That's going to give me 8x equals 16. And we'll divide each side by 8 to get x equals 2. Now we're not done here because we have to take that 2 and plug it back into one of the original equations. I could plug it into this equation, I could plug it into this equation, or we could plug it into the other equation that we solved for in the first part. I think it's easiest to plug it into this equation based on the fact that we already know y is all by itself. So we'll plug it in to the new one that we solved for. We've got 4 plus 2x, and it's really going to be 4 plus 2 times 2, which is 4 plus 2 times 2 is 4. 4 plus 4 is 8. So y equals 8. We've got x equals 2, y equals 8 for this problem. So I'm going to write my solution as an ordered pair, 2, 8. Please take the next 2 minutes just to make sure that between you and your partner, you guys do have number 3 correct. Check each other's work on this. When you are done with that, about 2-3 minutes on this, we're going to go into 18.2.